Welcome back, everyone. So today I'm gonna make a video. Today we're gonna take a break off linear algebra, and we're gonna make a video on part of our fun math series, and this will be regarding the area between the graphs ln squared of x and ln cubed of x on an interval AB. In this case, our interval AB will be the two intersection points of these graphs, as you can see from this little screenshot that I took on Desmos. And just to clarify, the red function on the screenshot is ln squared of x, and the blue function is ln cubed of x. Okay, so let's get started. So what do we want to do first? Well, first what we want to do is find the two intersection points. And as we know from algebra, to do that we just set the two functions equal to each other. So essentially, what's the x value when you plug it in, when is that going to be? When are the two functions going to be equal to each other? So let's check that. So let's set ln squared of x equal to ln cubed of x. We can just subtract ln squared of x from both sides. And let's see. So we have 0 equals ln cubed of x minus ln. I'm just saying ln, but I could just be saying natural log, right? Natural log squared of x, just like so. So now we can actually factor out a natural log squared of x out of this function here. So we have 0 equals ln squared of x times, we don't have to add that, Control Z, times ln of x minus 1. Okay, easy enough. So now either ln squared of x is equal to 0, or ln of x minus 1 is equal to 0, right? That's just basic quadratics, right? So let's set ln squared of x equal to 0 and ln of x minus 1 equal to 0. Okay, we can take the root on both sides of this. Doesn't look like a good root here. Obviously the square root of 0 is 0, so we get equals natural log of x equals 0. Okay, and remember that natural log is essentially just log base e of x equals 0. So that's basically what it is. So essentially e to the 0 equals what? Well, e to the 0 is just 1. Anything to the 0th power is just 1 by definition. So essentially we just get 1 as x. So our first solution is x, so x1 equals 1, and x2 equals, let's see, so let's add 1 to both sides. So we get when is ln of x equal to 1. So again, we have a base of e here, so e to the 1 power, e to the first power equals what? Well, x just equals e, right? Anything to the first power is just that same number. So x2 equals e. And that's going to be fairly interesting. It's not every day that you see an upper bound or a lower bound as e. So now we can actually get to the Riemann integrals. So let's see here. So we can see that the top function here is going to be ln squared of x. So that means we're going to do that first. And a visual intuition of that, let me show you. So I'm going to have to redraw the graph real quick. Let's see. So this is probably going to take me a few attempts. Oh, not bad. Actually, that's horrible. It's also bad. Oops. Okay, that's good enough. Just pretend like this actually intersects this here. And then blue graph is going to be like this. Oops. Okay, good enough, right? So essentially, just to remind you, whenever you want to basically find the area of this given segment that's like between these two graphs, then what you want to do is I'll give you a visual representation. Hold on, let me just check this again. You see, this is not a good visual representation. I'll just redo that completely. Hold on. This is going to be quite tricky. If only I could edit the ones up there. I just can't. That's why I'm doing it on here. Okay. This would be so much easier in person. If only I was actually in my house right now. Okay, that's good enough, right? They intersect here, and they intersect here. So this is 1, and this is E, right? I'll write in black. Okay, this is 1 and this is E. So what is the area between, we'll call this f of x here, and then g of x here. Just to remind you. So let's say this is function f of x and this is function g of x. So how do we find the area of this sliver here, this part here? Well, you'd basically find the area of f of x first, which is the top function, which is just going to be this entire area here, right? And basically you subtract from that the bottom function here, which is just going to be blue. And you see, when you subtract that, when you subtract the red, or the blue from the red, so basically we can write it as, so this is going to be the blue of f of x. I mean, this is the red, sorry. F of x minus the integral of, and this is the blue, so g of x dx. We basically get this area here. We get our area. Okay, and that's basically what we do. In this case, our f of x is going to be the red function, which is obviously ln of x squared. So let me get rid of all of this. So we have the integral from 1 to e of the natural log squared of x dx. Subtract from that integral from 1 to e of ln cubed of x dx, just like so. Okay, now we just have to evaluate this. You can use u sub technically, but I'm basically just going to use integration by parts, and we've worked this out in the past, so this shouldn't be anything new to you. So for the first one here, we'll just work out the antiderivative of the function. We can set, obviously we're going to set u equal to our logarithm, which is ln natural log of x squared. We'll write it as like this. This is the same notation, or different notation, but it means the same thing. And du, let's see, du, we just use the chain rule. The 2 comes down, so nx to the n minus 1 power. So 2 times ln of x, then times the derivative of the inside, which is just 1 over x. Okay. And that should be it for the du, and obviously we have dx here. And now for our dv, we have dx, so 1 dx, and integrate both sides, we get v equals x. And we could add plus c here, but then we could cross cancel. So okay, so v equals x, and now let's plug this in. So in general we get I'll write in brackets, so we got uv, or vu, x times ln squared of x minus the integral of v du. So it's, the x's actually cancel here, and we're left with, we can take out the constant too, and we have to integrate ln of x, simply. Dx, and we evaluate this from 1 to e. So now let's conduct integration by parts on natural log of x, right? So let's just do that. So u equals ln of x, du equals 1 over x dx, dv equals dx, and in general v equals x. And now we just plug this in, so we get natural log of x, so we get vu x times ln x minus the integral of v du, and this is our v and this is our du. Actually, oh wait, no, this is our v and this is our du. My dv looks like my du, that's unfortunate. And we see that the x's cancel, and we're left with 1 dx, and everyone knows this, there's going to be x. Right, we could factor out an x as well. So this is equal to natural log of x. Oops. So minus 1. And there we go. We're done with that. Now let's just plug it in to this formula here. And we just write it like this. So we can actually instantly factor out this x, both terms here, and yeah. So let's just do that. We get x times ln squared of x. You know, let's just avoid any error and just not bother with that, because this could easily result in some easy error. You know, we can do it. Well, fine, we'll do it. Ln squared of x minus 2 times 2 times, let's see, I'm just making sure I don't mess anything up. So ln of x minus 1. Okay. We could always take the derivative of this and see if this is actually correct. Should we do that? It's kind of a hassle. But you know what? We don't want to take any shortcuts, so let's do it. So we'll distribute that. We'll distribute the x throughout, and the minus 2. So we get x ln squared x minus 2x ln x plus 2x. Let's make sure we distributed that correctly. So we distribute the x into here, so we get that. We distribute the x here. Yep. Yeah, should be correct. Okay. And take the derivative of that. Du dx. And we get, so we use the product rule here, so we can take the derivative of the first thing. I'm just not going to go through this because it's fairly straightforward. So it's f prime of x times g of x plus g prime of x times f of x. So then we take the derivative of that plus 1 over, so plus 2 ln of x, and then times 1 over x times x. This cancels, and then we take the derivative of this, and we take the derivative of this. This is just going to go away. So plus 2. So let's just see, because we want to make sure this becomes just, okay, should be interesting. Okay, let's just continue. So take the derivative of this. We can take the negative 2 out, and we get, let's see. So we get minus 2 times 2. Let's see. So we take the derivative of that, so we get ln of x, and then we take the derivative of that, we get plus 1 over x. Oh, this isn't going well. X, so this becomes 1. Oh, this is going just fine, right? Plus 2, and that's our derivative. We distribute the negative 1. This cancels with this, right? And then this cancels with this, and we're left with that. So we got it all right? Going through the hassle is worth it. Well, maybe not in this case since we got it right, but still. So we can just get rid of all of this. Okay, now what do we do? This is going to be a 2-part series because this takes some time, right? Now what do we do? Well, now we just evaluate this from 1 to e, right? So we evaluate that from 1 to e, and we get, well, let's plug in e first. So we get e times ln squared of e minus 2 times ln of e minus 1, and then that minus, let's write it like this. Let's get rid of that and write it down here. Okay, plug in 1, we get ln squared of 1 minus 2 ln of 1 minus 1, and there we go. So let's simplify. This equals, so e times, well, natural log of e all squared. Let's see, so it's base e. I kind of want to write this out, but it might take too long. Let's see. So we get ln of e base e squared. I just want to write this out so you guys can understand. So e equals x, so we want to find x. So e to the x equals e. Well, then x just equals 1, right? Simple. So this simplifies to 1 squared, which is just 1. So e times 1 minus 2 times, well, ln of e, that's the same thing. It's just going to be 1 minus 1. This cancels out to 0, as you can see. So this entire term just goes away. So we can just simplify this to e in this term, right? E. Okay. Minus, let's see, so we get ln squared of 1, so ln of 1 all squared. So e to the what power equals 1? Well, just 0, right? So 0 squared is 0. And 0 minus 2 times, well, let's see. So minus 2 times ln of 1. Again, this is just going to be, this is just going to be 0. So 0 minus 1. In general, all in all, it just simplifies to, e minus 1. Right? That's the, minus 2, sorry. Because we distribute the minus, let's see, yeah, it's definitely going to be that. Okay, well, there we go. So that is our, it's not our answer, that's not our area yet, but we see that we can just say that 1 from e of ln squared of x dx equals this. So now we want to find 1 e ln cubed of x dx equals what? So now that's what we want to find, right? So that's all we're going to do for today. We made some good progress, right? So we're just going to stop for today, and we're going to continue in the second part of this epic saga, right? Okay, so see you in the following video, and have a nice day.